Here you saw that I have got a CLR, okay, direct from the fuse passing one diode, I have got a CLR. After that CLR, it is going to a P channel MOSFET, and from P channel MOSFET I am getting a Vin. This is a discharging MOSFET, this is a P channel MOSFET. Anyway, let us go to another. I wanted to show you some D701P. Okay, done. D701P, D701, D071P, D071P, Inspiron 558. Yeah, I am going for a latest motherboard, brother. This is a Skylake. Remember, this is a Skylake processor. So in processor, in CPU class I will explain you. See, Skylake processor, okay, you don't have PCH, you don't have nothing, you have an IO controller and only a CPU. And let us see for the Vin chart. Where is my dear brother Vin? Charger IC. This all I will teach you. This all for the last classes. Okay, timing diagram, chart. That are last classes. Yes, this is my charger IC, I think. Yes, and this is my Vin chart. Okay, so I think from here the DC jack is starting. So this is my DC jack, and adapter present 19 volts. Okay, I am getting a 19 volts after passing a coil. This 19 volts is going here. Okay, this 19 volts is passing here. It is passing to the first MOSFET, and this is an N channel, and from this it is passing to one more MOSFET, that is, this is also an N channel. So this needs permission. Why? The diode is blocking the voltage. This doesn't needs a permission. This is a forward bias. Okay, when I am speaking about permission, I need a voltage here. That means I need someone's help. So who is going to help here? Let us see. This AS gate. That means the help is given by my charger IC. Very good. So after charger IC, I got my CLR. You can see I got my CLR, and from CLR I have got 19 volts for battery section, and this 19 volts it is going to a again N channel MOSFET, and 17.5 volts. You can see 17.54 volts is my Vin. So in many sections the Vin is generated from the charger IC, and you will get 13 volts. Let me show you one more architecture. Okay, let me show you Gameron. D80. This is also Skylake. Okay, so always what you think, the Vin is 19 volts only. Okay, but due to the architecture requirements, the Vin voltage will be converted to 13 volts. Okay, when here also it is showing 17.4 volts only. Same architecture. D801P, D701P, D071P, same architecture. I will show you Goliath. Gameron. Where is Goliath? No. Yeah, Goliath. This is an hard Haswell CPU. Okay, Haswell. That means 4th generation. Skylake was 6th generation. Okay, let us go for the Wien part. Dell 3542, that all comes under Haswell CPU only. This docking station. Yes, this is my Wien. Yeah. Here, yeah, this is my Wien. This is what I was trying to tell you. DC in means voltage coming from adapter. Proof you will see here from a DC jack. Where is my DC jack? Anyway, I will show you that. Let me clear this. Yeah. DC in underscore SS. So I am in page number 47. This will be generated from your DC jack, correct? Yeah, you can see docking underscore bar, DC jack, anyway. Okay. This is the architecture. Automatically it is showing me. Let me go forward. DC jack. You can see I have got my DC jack. From DC jack, after passing a coil, after passing one P channel MOSFET, I got my first voltage. Remember, after passing my first MOSFET, I got this. Okay. Anyway, coming to page number 44, correct? Yeah, 47. So this is my voltage coming after passing my first MOSFET. This is my second MOSFET, and this is a P channel. So when I told you P channel means the gate support should be given from my charger IC DC block GC. Okay, gate control. You got your A plus SDC. Passing the second MOSFET DC in, you got your CLR. Current load resistor, and usually what we are getting, this was our V in. But in this latest Haswell architecture, up till here it is your 19 or 20 volts only. Okay, no difference. Up till here it is 19 volts only. But in this architecture, the V in, okay, after passing this a jumper, you got a charger SRC. Okay, that means source, power source, and this charger IC will take all the requirements. After getting all the requirements, you will get your power SRC, and here you will have 13 volts. See there, here also we have a CLR, that is for the charging section, but here power SRC. See the difference here. Here it is written as power SRC AC. AC means 19 volts coming from adapter. Here you are getting one more power SRC coming from charger IC. That means you will have 13 volts. Okay. So these 13 volts will go to every section drain of the upper MOSFET. This is very important. If this 13 volts is not coming, your laptop will not power on in any scenario. It will not power on, it will not power on, it will not power on. For this, you have to complete the requirements of your charger IC. Okay. So this is not important to me. Why? This is important. Charger IC and this 13 volts is the requirement. So now let me go to any of the section. Let me go to any of the section. PWM section. You see, any of the PWMs and drain of the upper MOSFET, you are getting power underscore SRC, which was coming from the charger AC. You see, drain of the upper MOSFET, power underscore SRC, that means charger AC. It is coming from charger, it means it is 13 volts. Got my point, brother? This is what I want to tell you, the different types of V-in, what is the help of VH28IC, and different types of switching, gate switching. Understood? Clear? Exact 30 minutes.
Yes, sir.
So now you are sure. Sir, now you are sure, correct?
Yes, sir.
Very good. So these all things will help you very much, brother. Mustafa. So today you all members are clear about the V-in part, correct?
Yes, sir.
Sure, confident.
Yes, sir.
If you are confident, tell me what are the requirements, what are the help, what are the semiconductors and which help to generate a V-in. Step by step, tell me. We need first MOSFET for the switching, correct?
Yes.
Next, second MOSFET,
This second MOSFET.
and we need the help of charging IC to switch the MOSFET, correct?
Yes, sir.
We need a AC in confirmation, am I right?
Yes, sir.
The AC information, AC in confirmation should go to IO controller, correct?
Yes.
We need 20, if 28 volts IC is there, we need to complete the requirements of 28 volts, correct?
Yes, sir.
In latest Haswell motherboard or Skylake or KB Lake, the V-in voltage will be generated from the charger IC and it will be converted to 13 volts. Clear?
Yes, sir.
Good. Good. So any other members, any doubt here? So today V-in is completely clear. Done? I have taught you semiconductor, transistor, diodes, MOSFET, how to trace, how to check the value, which is N channel, which is P channel, the switching roles, complete architecture I have taught you. Done? Answer me. Abdul Rashid, Ahmad Isa. Good.
I have a little challenge.
Yeah, tell me.
Now, where we have the boosting capacitor for 28 volts, now you have,
I see.
can you hear me, sir?
VH28 IC.
For, yes, sir. Now, you have the AC in confirmation from the charger IC to that IC and also to IO controller, sir. Now, you made mention when we have challenge, you can cut off the IC AC in.
If there are simultaneous two tracks Y shape, okay, if there are two informations, so what is important to me? From the charger IC to the IO control is important to me, okay. VH28 IC is not important to me, so that time I will cut the track of VH28. Clear?
So, sir, why do you need to cut? No, sir, why do you need to cut out the VH28 when you have a problem of LED not glowing?
Because the VH, see, that is a switching, gate switching, so there should be a high voltage, 1.2 volts should come there, okay. But what happens, because of the internal problem of the IC, a grounding will be negative voltage will going to the AC in, and that will not tell the information to the IO controller that adapter is present. In this scenario, the IO controller will not release the adapter present LED, okay, the white LED will not glow. So that's why, see, one VH28 IC there is a problem. IO is okay, charger IC is okay, but VH28 is doing a disturbance. It is sending a negative voltage, ground voltage to the IO controller as well as charger IC. That's why what we do, we cut off the track. Now there is a direct communication between the IO controller and charger IC. So when the information is received to the IO controller, this IO controller will release adapter present information and it will give a voltage for the white LED to glow. Clear? Very good. So any other doubts? It's a good question and good doubt. So I am telling you about a practical experience. Okay, theory, when you need a theory, you need a practical experience also. When these two combines, you will become an expert. Theory is like a map. You are going for a destination, you are going for a treasure hunt. What is a practical? Practical is a perfection. Like learning swimming by theory is different. Practicing swimming is different. So without learning, you cannot practice. If you don't practice, learning is of no use. Same like a swimmer. Here also, you know theory, but you don't know practical, it is of no use. You know practical, but you don't have theory knowledge, again it is of no use. So you need parallelly both. You need theory, practical. So you should learn, you should start tracing, you should start practicing, and you should start troubleshooting. Then you will get experience. Okay? Stop asking help. Learn by on yourself. Done? Answer me. Clear? Mustafa.
Yes, sir. Yes, sir.
Very good. So today I will stop the class here. Monday I will be taking a charger IC. Yes, answer me. Tell me. Very good. Okay, very good. So now I will increase the speed. Now the speed was very slow. Okay, down the line I am going to increase the speed because I am not going to explain about semiconductors. I am not going to explain about the conductors. I am not going to explain about the components. Directly I will be going to the IC requirements and function. Now V in part is completely closed. We will go for the charger, battery part, charger section, charging, not charging, why charging not required, what are the pin details, every pins, how it will work, very very important. So go for the charger IC. See, when I spoke about my V in section, a subject automatic came about charger IC, correct? So that means now I have to automatically read about the charger IC. Okay, who was the helper? The helper was my IO controller. So when I am learning about V in, IO control was there. When I learn about charger IC, then also IO control will be there. Okay, so now these are the basic sections which we will be learning: V in section, charger section, and IO controller requirements. Automatically there is a link, one by one there is a link. There will be a communication, interaction, that itself will teach. That means what I have to learn, second is what I have to trace. Okay, it is nothing, same. What I have to learn is nothing but same what I have to trace. Done, brother? Okay, so here let us go for the block diagram, okay, of a charging section. So before charging section, I would like to tell some few things. Okay, we have two circuit. One circuit, the voltage is coming from the adapter. Okay, what is the main goal of the path? The voltage has to reach my V in line, so V in path. Okay, so one more goal, the voltage has to come to me from my battery part. What is the goal? Even this voltage has to come to reach my V in path. Okay, it has to come and reach my V in path. So this is my battery connector. Okay. Now the common sense is, why we have a common path here, let us understand. the path present here, it will be going to different sections. Like I have my standby section, this voltage has to go to standby section. Okay, I have my RAM section, I need a common voltage to go for a RAM section. The same, I need this voltage to go to my charging section also. Okay, charging section to charge the battery. This will go to PCH. This is a common, you all know what I am trying to tell. This voltage will go to my termination voltage, okay, of CPU. This will go to CPU core and GPU core and GFX core, GFX, CPU and GPU. Okay, all this voltage. That means this is the main path, it has to come. But what is the rule? Either the voltage has to come from the adapter, or this voltage has to come okay, done. Getting my colors. So adapter, okay. So the rule is, for this main path, the voltage has to come either from the adapter. That means when the adapter is connected, my V in voltage will be minimum 19 volts. That means I can play with minimum 19 volts. Okay. But when my battery is connected, the voltage passing to the V in, it should be around 10.8 volts. Okay, 10.8 volts. This is what I want. Okay, but this is the same. The voltage available 10.8 to 11 volts, 11.2, 11.8. This is the standard voltage of battery. But my laptop has to work with either of the voltages. Either it should be adapter, either it should be battery. Okay, either voltages. Either one voltage should be available. So what is the condition? When adapter is present, the battery voltage will not work. Okay. When adapter is not present, the battery voltage will come inside the laptop. Third part, when adapter plus battery is present. Okay, see, first scenario what? When adapter is present, battery voltage will not come. Okay, when adapter is not present, battery voltage should come. Okay, this is scenario 1, this is scenario 2, and this is scenario 3. When adapter plus battery is present, what happens? The voltage present in the V in, it will be adapter voltage, and the battery will go for a charging condition. Means when adapter present, the battery voltage should not come, means this is the voltage should go to off condition. When the adapter is not present, the voltage should go to on condition. The voltage from battery to V in part should go to on condition. Okay. When adapter plus battery is present, the battery should go for the charging condition. Okay. Again, the important part is when adapter, that is point number 4. Point number 4. Okay. When battery is 100% charge, when the battery is 100% charge, the adapter should go for cutoff. Adapter should go for cutoff. Why? Overcharge should not become. You will lose your battery life. So these are the 4 rules to understand about basic voltage of voltage part. Okay, from adapter to your till your battery part. Clear? From adapter till your battery part. Let us go forward. So who will speak to me? Whose audio is clear? Frank, your audio is clear? Are you taking class now? Are you free? Frank. My dear brother Frank.
I'm taking class, yes, sir. I'm taking class with you, sir.
No, not with me. You are taking class with your other students?
Yes, sir. Yes, sir. I'm taking class with my other students, sir. No, I'm taking class I'm taking class here now to speak.
No, I mean to say, are you free? You can speak with me, or are you busy with your other students? And my question is simple.
I'm free with you now.
That means you can interact with me. Am I right?
Yes, sir. Yes, sir. Yes, sir.
Yeah.
Yes, sir.
My question was, I have an adapter connected in my laptop and I have a battery connected in my laptop. Okay, battery. So between the adapter and voltage. So I told you 4 scenarios. Can you explain me 4 scenarios?
Yes, sir.
Please.
One of the scenarios is that when adapter is plugged in.
Yes, when adapter is present.
When it's present, the battery will go to off condition.
Very good. The battery will go to off condition. Second scenario.
When adapter is also when adapter is also present. When adapter is present, okay, let me put it this way. When battery is 100%.
Pardon me?
When the battery is 100% full, like when it's charged, when the battery is charged.
Okay, 100% charged.
100% charged.
Okay.
The charging section will go to off. The charging section will cut off.
The adapter will go to cutoff, correct?
Yes.
Okay.
I think that's what I can remember now.
When adapter present plus battery present,
Yes.
this should go for a charging.
Charging. Yes, sir.
When adapter is removed, the battery will have V in voltage, 10.8 volts,
In voltage.
correct?
Yes, sir.
When adapter is present, you will have V in voltage from adapter, that is 19 volts, correct?
Yes, sir.
So these are the basic principles of the voltage chart, correct?
Yes, sir.
Very good, very good. Now for the magic. Okay, I have a circuit that my IC, I have a battery. Remember, I am putting in simple language, I am not going so much complicated. Okay, I will explain you. I have my adapter, I have three things. Okay, what all I have? I have charger IC, okay, I have adapter present, I have battery present, and I need one more component also, that is my IO controller. Now the IC work has started. Till now here we did not have any IC. Okay, now the IC function has started. As you all know, when our question will started when. Second question is how. Okay, when the adapter will give a information, or when the charging IC is going to charge the battery. The question is when. The answer is when a battery present, when a battery present plus adapter present, both information should reach the charger IC and the IO controller, then only the adapter will charge the battery. Correct? So if battery is not present, adapter present confirmation is there, but battery present confirmation is not there. That time the charger IC will not work and it will not charge the battery. So the charger IC is divided into two parts. Part A, part B. A is related to adapter present. Okay, A is related to adapter present. B is related to battery present plus battery charge. So I'll have an inductor here. Okay, mark my question, mark my words, what I am trying to tell you. Okay, see, my charging should work. So what is the information that is going to the charger IC, that adapter present is there and battery present is also available, so that with the help of the adapter, the charger IC can charge my battery. What is that information? Point number one. Point number two, what is the information that is reaching the IO controller, so that if the battery is 100% charged, this will cut off the adapter present. This will go for an adapter cutoff message. Now, how will the IO controller come to know that the battery is 100% charged, and what is the information it is parallelly passing the charger IC to tell? See, one is adapter cutoff, but after adapter cutoff, charger IC should not charge, correct? So what is the information which is telling the charger IC that the battery, either it will be enable or charge or battery full? This type of information should reach. Understand? Okay? So step by step, adapter is present, battery is present, this charger IC will get a confirmation that adapter present and battery present, then this will charge the battery. Okay, so the battery charging information is going to the IO controller. Once this reaches 100%, the IO controller will give an adapter cutoff information so that the adapter present will not come here. If adapter is not present, this charger IC should not charge the battery. So this will give a information to the charger IC also, telling that this much percentage the battery is charging. So maybe it is 10%, 20%, 30% battery is charging, and there should be information and a confirmation telling that battery is present. Now you can charge for the battery. So when adapter is present, this information also should go to the IO controller, that adapter present. So this whole architecture, whole game, how does it work? Okay, let us work. Sorry, adapter cutoff. Frank, understood this? My dear lovely brother Frank, Agido, Osai, Frank.
Yes, sir.
Very good, very good. Now, when the adapter, suppose this is my adapter, this is my battery, okay? When the adapter voltage is injected in the laptop, the battery will go to off condition. Okay, understand? The battery will go to off condition. When the adapter is removed, the battery will go to on condition and this voltage will pass into the laptop. Okay, condition number 1. When adapter present, the battery should go for a charging condition. When the charging is 100% full, the adapter should go to off condition and this battery voltage will pass into the laptop. So you will have switching condition in your laptop. Done? Frank, you should reply me fast.
Yes, sir.
So let us see here. Okay, let us see here. So this is my adapter voltage which is coming here. It is coming here also, it is coming here, and this is my V in part, and this voltage is stopping at my diode. Okay, but because this is an N channel MOSFET or it is a forward bias, this voltage also should not come here. What is this voltage? This is my battery voltage, correct? Even this voltage should not pass here, so that there should not clash here. So what happens? This gate is controlled. This gate is controlled by my charger IC. Charger IC. Okay. That means because this is an N channel, suppose if I am giving, what is the condition of for an on condition? 10 volts to plus 30 volts. Suppose if I am giving 5 volts here, what happens? This will go to off condition, correct? This will go to off condition. So when this goes to off condition, only adapter voltage will be flowing into my V in path. When the adapter is full, when the battery is 100% charged, this minus voltage will be released, negative voltage will be released, so that it automatically will become an forward bias, so that the battery voltage can come inside here, but condition is the adapter cutoff should happen. So this again, this gate is also controlled by charger IC. That means in this scenario, the charger IC plays a major role, correct? So the charger IC is deciding whether it has to cut off the adapter MOSFET or it has to cut off the discharging MOSFET. The MOSFET connected to the battery positive point is called as discharging MOSFET. So Frank, what is the name of this first MOSFET? What is the name of this MOSFET?
The main MOSFET. Main MOSFET.
I did not taught you main MOSFET. Did I teach you?
Second MOSFET, sir.
Did,
Second MOSFET, sir.
did I teach you second MOSFET? You can see the cutoff system is happening here.
Question again.
Huh?
Yes, sir. What's the question again, sir?
My question was, this is a discharging MOSFET which is connected to the positive of the battery. Sometimes it will be P channel, sometimes it will be N channel. But if you see here, it is an N channel. Okay, so it is not mandatory, always it has to be a P channel. Now, if this is a discharging MOSFET, what is the name of this MOSFET? This MOSFET is called as adapter cutoff MOSFET. Why? Correct? Why? When battery is 100% charged, this charger IC is making a cutoff. Correct? When this cutoff happens, this battery voltage is reaching. This battery voltage is reaching my Vin port. Correct? My goal is I should have a Vin. Correct? So here my charger IC plays a major role. Point number 1. Correct?
Yes, sir.
Very good. Very, very, very good. Now, when my battery is present, how will and who will give an confirmation? Anyway, first I'll complete this. As I told you, adapter present, I have given 2 confirmations yesterday. Am I right? Have I given the information or not? Adapter present.
Yes, sir. You have, sir.
Yeah, when adapter present, that means AC present information is given to my IO controller. Correct? Yes or no?
Yes, sir.
Very good. When the AC present information is given to the IO controller, you can see that AC LED on will be released. AC LED on will be released from the IO controller. Okay. You can see here AC LED on is released from the IO controller. Let me show you page number 30. So in page number 30, you can see this is an IO controller KB3940QF. On the right bottom corner also I will show you, it is a EC KB3904A1 ROM. Okay, we have BIOS, and here this is giving an confirmation that AC LED on. One more confirmation, battery LED on, means when adapter is present, that information will reach the IO controller. What is that information? The information is AC in, adapter present, adapter type and adapter select. That means this is the architecture present here, that is adapter type. What is adapter type? When adapter ID, because this is an HP, you are getting an information here. That means you will have a voltage. How much? 1.2 volts minimum. This voltage will coming from my HP adapter. When this voltage is coming from an HP adapter, you have a forward bias, thus will be connected to 3 volts always, and you will have an adapter type confirmation given to the IO controller. Adapter type means how many watts, which watt, which adapter, whether it is an original adapter or which adapter is present. This adapter type will go to here pin number 64. You can see this adapter type is connected to pin number 64. Next, when pin number 64, one part is complete, that means what type of adapter? Now we'll go for how many watts. Okay, now we'll go for how many watts. Now if 3 volts is connected, GPIO 42, this is an information which will tell the IO controller how many watts adapter is present, whether it is a 65 watt adapter or 90 watts adapter. Okay, so how will it come to know whether it is a 65 watt adapter or 90 watts adapter? Now GPIO 42 means it is a pin of IO controller. Here if a resistor is connected to high voltage, that means here I mean to say 3 volts. If this resistor 10k resistor is connected to high voltage, it is trying to tell me that it is a 90 watt adapter. If the same resistor is shifted to ground, you can see star mark if it is not present. If the same resistor from here, if it is shifted here, this will identify low, that means UMA means it is a 65 watt adapter. Okay, why 90 watts adapter? If I have a graphic machine, mandatory the adapter should be 90 watt. If it is not a graphic machine, I can run with 90 watt also and 65 watt also. Okay, so here I have an option of 65 plus 90. Okay, but for my graphic machine, discrete machine, compulsory I need 90 watt only. So who will tell the IO controller? These are the resistors R878 and R879. Either this resistor is present, it will tell high. If this resistor is removed and connected here, that means optional. Connected to ground, that means low. It will understand it is a what? 65 watt adapter. So this is second confirmation given to the IO controller. So GPIO 42. Where is my GPIO 42? You can see here on the left side. Is it available here? GPIO 42, and comes my confirmation either left or the right. GPIO 33 and GPIO 42. So, I can see, gentlemen, I can see. So you saw that pin number 75 is an information to the IO controller, whether it is 65 watt or 90 watt. So many times you have seen that laptop doesn't charge, or say original adapter is not present, it will not work. Okay, so how many information confirmation to the IO controller? Confirmation number 1, adapter type. Okay, adapter type. Confirmation number 2, adapter select. Select means how many watts. Okay, how many watts adapter is present. Confirmation number 3, what is the confirmation 3? Adapter present, that is AC in. This is adapter present. All are different. Adapter type is different, that whether it is HP adapter or Dell adapter, whether it is input output, whether it is original or duplicate, whether it is you are using DC supply or China made. Second, how many watts? 65 watt or 90 watt. AC in means adapter is connected and a confirmation is given by charger IC. When these three informations will reach the IO controller, this will release, IO controller will release AC LED on. Understood now? When the AC LED will glow, AC LED on. Okay. Now AC in, let us say where it was. As I told you, it was coming from the charger IC and it has to come to my IO controller. Okay, AC in. It should come from page number 34 because 34 is my charger IC. So I am seeing here page. It will be easy for me. Okay. See, AC present, one confirmation that we can see later. Let me check for AC in, which is coming from page number 34. Yeah, you can see from page number 34, I am getting AC in confirmation to my IO controller. Okay. Why it is an arrow mark? Because in between I have my VH28 IC also. Correct? Where this AC in is also reaching there. Okay, VH28 IC also is coming here. Correct? That's why you can see. So never always understand, go for a arrow mark, it is coming inside or outside. Sometimes you will have a difference, but I am telling you the path how to identify. So when AC in confirmation is given, that time this IO controller will release AC LED on. This is one part. Unless and until your white LED will not glow, that is, let us go to page number 34. Okay, AC LED on is coming from my IO controller. That means I am getting a high logic. Okay, high. When it is coming here, it is hitting here. So arrow mark outside, that means N outside. So P is my base. That means if I give a positive, this will go to on condition. So by default, the IO control is giving a high voltage positive. When this goes to on condition, what happens? The ground voltage will go here. But you have an hash mark. You can see here hash mark. Hash mark means by default it was high, but the IO controller will give a different information. That means it will give a low logic. That means ground voltage. When ground voltage comes here, this will go to off condition. When off condition goes, okay, when it goes to off condition, you can see one it is in red color, one it is in black color. But the hash mark here, it is trying to tell me sometimes it will be high and sometimes it will be low. Okay, so what happens? Okay, so now I am telling that if it is grounded, that means if it is low, here also it will be low. Okay, here also it will be low. When it is low, same NPN transistor, this will go to off condition. When this goes to off condition, the voltage present here, the voltage 12 volts present here, it will come here, and this JFET will go to on condition. When this JFET will go to on condition, this 5 volts will pass your 2.34K resistor from here and it will go here and your LED will glow. Okay, and what is this LED? It is an white LED, white color. Okay, it is a white color. Understood? If it is low logic, if the information is not completed to the IO controller, instead of low logic, the IO controller will give an high logic. That means high voltage, maybe anything positive voltage. Okay, 3 volts. If positive comes, what happens? This will on the JFET, the ground voltage will go here and you will have a protection here. This will go here, the ground voltage will go here and your LED is in off condition, and here also you have a ground, and this diode will work as a protection. Anode is connected to ground and cathode is connected to supply. It will go for a protection. So the whole game is the IO controller should get all the required information. When my white LED is growing, it is 100% clue to me, which is telling that IO control, all the 3 requirements are completed related to my adapter. Got, brother? My dear lovely brothers.
Yes, sir.
Interesting.
Yes, sir. Yes, sir.
Someone is sleeping.
Interesting, sir.
Hey, someone is sleeping. Anselm is sleeping.
Nobody is sleeping, sir.
Anselm is sleeping. AC LED on hash mark. Now you got?
I'm sleeping, sir.
Huh?
Yes, sir. Yes, sir.
You are sleeping.
I'm not sleeping. No,
Ah.
sir.
Why? Why are you not sleeping? Answer me.
Yes, sir.
See, this is one part. So
The classes.
this is one part and very important. Why I am telling it is very important? Hello. Anyway, coming back, why I was telling it for important. Whenever I connect an AC adapter to an HP, my white LED should glow, should glow, should glow. Okay, in YouTube you can see my demo 1 video, demo 1. Okay, in YouTube demo 1 you can see. Let me share the link also here if it is available. Okay. Oh, come on. My channel, videos, where is my demo 1? First day online class, is that? No, it is demo 1. Second day online class. Yeah, this is my first day online class. Okay, so I will share this. In some part it is
voltage is okay.
in some part,
I'm getting display. It doesn't mean
okay, in some part what it is, I have spoken in Hindi. Okay, okay, in some part, in the beginning I have spoken in Hindi, my local Indian language. Okay, but why I am trying to tell you here, in the last stage of the video, you can see that I have live shown the practical, the clue about the light, white LED blinking. Okay, if it is 2 blinking, if it is 3 blinking, what are the steps? Maybe almost the same board I have shown there. Okay, I have shown about VH28 IC also, but I have not told to cut the track there. Okay, because it is a demo class, I have not explained about that there. Done? Got it, gentlemen? Now sure, HP means LED should glow, correct? Down the laptop. Let me switch my camera. I am showing a live proof to you. I have shut down the laptop. I am going for a shutdown mode. You can see I have given a shutdown command. So it's already shut down. No lights. So let it take time. Now only 2 lights are blinking. If this light goes, laptop is shut down completely. No lights blinking. Okay. Now without pressing power button, let me connect my DC jack. I am connecting DC jack. Let me check for any lighting. You can see one red light has come. You can see one red light has come. When I connect DC jack, you can see one red light has come. Okay. See the ampere there. Let me show you the ampere. होठों पे तेरा है, उसका उसमें लगा लिया हाँ आँखों में आँखों अच्छा let me show you proof. So the question is, can I solve this issue? Okay, the question is, can I solve this issue? So actually it is possible, it is simple also. Only thing is I have to work on it. Yes, tell me.
I had a little issue with my network, so I don't know what was the issue with the laptop you are trying to show.
The laptop is getting powered on with the battery, but from adapter it is not getting powered on. Got my point? Laptop is okay with battery, but from adapter it is not working. Now give me the answer. So you can see DC power supply here also on my left corner. You can see DC power supply. So I have given a reading also. Let me connect my DC power supply with the laptop. Okay, with the laptop. You can see one red light is glowing here. You can see my red light is glowing, and you can see there the battery is charging. That means in off condition the battery is charging, but when I press the power button, when Windows comes, the laptop is not charging. Got my point? Power off condition, battery is charging. Power on condition, battery is not charging. Suppose now let me power on the laptop and see the scenario. But the laptop is not powering on. See, I am pressing it. Yes, got power on. Let me check whether battery is charging or not. You can see that it is showing charging. But charging symbol is not coming. I don't have charging symbol. Anyway, to tell the proof, I don't have a charging symbol here. You can see I don't have a charging symbol. You can see here carefully. I don't have a charging symbol. But here it is showing the battery is charging. Okay, now let me remove my DC jack. I have removed my DC jack. My DC jack is heating. Let me fix it back. Now if you see, the ampere has changed. it has not gone to 2.0. Now it is only in milliampere. It is trying to charge, it is trying to come back. It is trying to charge, it is trying to come back. And the battery percentage, it is showing as 71%. If I remove, then also it is showing 71%. If I put power on, DC jack, then also 71%. So now let me come to the question and answers. You can see the DC power supply 700, 800, 900, 6, 7, 8, 9. You can see 3 readings. So let me shut down the laptop. After I shut down the laptop, you can see the ampere will change. Automatic the laptop also, see, you can see it will go for the charging mode. Let it shut down. Now it, yeah, completely shut down. The laptop is completely shut down. You can see automatically the charging has started. Okay, I will solve this. Okay, for this let me go for a question with yours. Open karo. Now let us close this DC power supply. For a charging section, okay, how much hour? We have got 52 minutes class. Very good, interesting. Okay, shall we continue? Interesting.
Yes, sir.
All are getting interested?
Yes, sir.
Sure. I am not getting confidence. Only 6 members are there.
Yes, sir.
Shall I continue? Idris, Abdul Rashid, Mustafa, Isa, Anselmi, Ahmad Isa,
Continue, sir.
Emmanuel.
Yes, sir. Continue, sir.
Good. Very good. Now we will go for the proof. Okay. The proof number 1 is, we will start from here. When AC in, that means my DC jack is connected, that is my DC in is present, whatever the adapter voltage, okay, adapter voltage is present, this will get a confirmation. Now there will be a voltage divider resistor connected here, voltage divider resistor connected here, and this will tell the charger IC, what it will tell, that AC okay, that means adapter present, AC okay or adapter present is there. Here AC in is present. Once this confirmation is released, this will give an output telling to the IO controller, what it will tell, my AC in is present. Sometimes, see this, whatever I am writing inside the charger AC, it is called data sheet. Whatever I am writing outside the charger AC, it is called as schematics. Okay, so sometimes AC in will be in data sheet, sometimes AC in will be in charger IC. Okay, so this circuit is very important. Now you can ask me, how much is the AC present voltage? It depends upon different charger IC. Sometimes it will start from 2.8 volts and maximum it will be 3.1 volts, not more than that. Okay, so from 2.6 I think I can take a list of 2.6 volts and maximum of 3.1 volt, not more than that. If it is more than that, the AC in will not come. Okay, the AC in output, here it is DC in. Okay, AC in present will not come. See, this is called as first confirmation. Understood, brothers? So without pressing power button in my laptop, the battery was charging, which told the IO controller that adapter is present and AC in confirmation has come. Now if the AC in confirmation has come, it is time for my IO controller. here you can see A scene has released, and this A scene will go to IO controller. Now the IO controller will wait for two things. One, battery present. Battery present. Why? Adapter present, information is complete. Adapter present, information is complete. But battery present information still IO control has not received. So this will get an information of data. This will get an information of clock. This will get an information of temperature. Okay. The same data and clock will reach. Sometimes it will go to charger IC. Sometimes it will not go to charger IC. So these two, data and clock, it is not mandatory. Okay. It has to go to charger IC. In some circuits it is required. In some circuits it is not required. Done? Temperature, this will not go to charger IC, it will go only to the IO controller. Done? DDDC वाला है ए मेरा कोरियर आपको है सर now when the IO control gets a confirmation that adapter is present, when IO controller gets a confirmation that battery present, this will give an enable voltage here to the charger IC. Sometimes enable voltage is given by the IO controller, sometimes the enable voltage is given from here. कहाँ है? So sometimes it will come from charger IC, from the voltage divider, sometimes it will be from my IO controller. Once this information is released, now my charger IC will start charging my battery, and this voltage will go to my battery. So this is my B plus. Understood? One step I have told you. Clear here? Up till here clear? Mustafa.
Hello, sir. Please come again, sir. Come again, sir. I have a little problem with my network, sir.
Okay. Not an issue. Let me show you now. See here. This is A, means a confirmation has to come from the adapter. When adapter confirmation released, this will release AC in. Okay. The AC in is going to my IO controller. That means adapter present confirmation is fulfilled. Now next is battery present. This information has to reach to my IO controller. So there will be one data clock, one clock pulse and one temperature. This will give a confirmation how much percentage that battery health is available, whether it is 10%, 20%, 90% or 100%. Okay, if it is 100% charge, the battery will not go for charging condition. If the percentage is less than 100%, okay, then charging is required for the battery. Very simple. Now if the percentage is less than, if it is less than 100% the IO control will is enable to charge for the charger IC. Now the charger IC will release my battery positive, okay, to charge my battery. Sometimes the enable is given by the IO controller, sometimes the enable is given from my voltage divider AC in circuit. Now clear?
Clear, sir.
100% clear, sir.
Huh?
100% clear,
Yes, sir.
sir.
Very good. That means you are improving now. Good. So can we go forward? Now you understood the language of schematics. You understood the language of communication. Now it will be easy for us to communicate more. So I can increase my speed now. Am I right?
Yes, sir.
I am not getting reply from other members. I want to hear their voice also. What happened to their voice?
Yes, sir. Yes, sir. You can continue, sir.
बैटरी कनेक्टर कहाँ है?
Sir, I have a question.
Yes, please. Isa.
Hello. Okay. Sometimes it will show battery charging and the battery will never increase. So what is the...
That is there are some physical faults of the battery. Okay. There are, I told you, the battery working condition also should be good. I told you the third part. My adapter is good, the same wattage. Okay. I told you about the IO controller, adapter present requirements, adapter select, adapter type, and how many watts. Everything has to be confirmed to the IO controller. Second, to the charging IC, what? Adapter present, my voltage divider AC okay, and AC in information going to the IO controller. This has to be completed. Third, what did I tell you? There should be a communication between the battery to the IO control. That means my data pulse, clock pulse, and my temperature pulse. Third question. Fourth, my battery shells also should have a good health. Okay. If my battery itself is not healthy, my battery itself is not good, then what is the use? Correct. So you have to test with an working battery also. Suppose the battery is charging, the charging is stopping at 50%, 60%, any one standard place. What you will see? Suppose it is 50% or 60%, what you will see? It is not charging or discharging. That means that my battery is faulty. Clue number 2. Clue number 1, understood? The percentage is not increasing from 50 to 60, 70 it is not increasing. Clue number 2, when you connect an adapter, the charging LED starts blinking. It is not constant. I told you, when battery is connected, you should get a confirmation near my DC jack with the amber LED telling that my battery is present. If my battery is present at my DC jack, amber LED, maybe orange color, maybe red color, you will get a confirmation. Okay. It is not blinking, it is confirmation. If it is blinking, that means battery confirmation is coming to the IO controller, or again it is going back. It is coming to the IO controller, again it is going back. That means battery is faulty. Okay. In schematics, you can see here, when my battery is connected, you can see MBAT LED. When battery is connected, even adapter is connected, a confirmation is given by the IO controller telling that my battery is okay. Okay. So this will go for a low logic. When it's go for a low logic, the transistor goes to off condition. When this transistor goes to off condition, the 12 volts present here, it will be passed here. I'll tell you from where we got the 12 volts. Okay. So this also it is going for low logic, okay, given by the IO controller. So when this goes to on condition, this 5 volts will pass here and it will go to tell that my battery is present. You can see here, this is going to my LED to pin number 8. You will get an LED. So one is adapter present IO confirmation, another is battery present. Battery present as well as battery is charging. If you are getting a blinking there, if the light is blinking, that means IO is not getting a clear confirmation that my battery is charging or not. Sometime charging, sometime not charging. Understood, brothers? So I think now we are ready to go for the charger IC. Anyway, all welcome back to the classroom. Okay, so we'll activate our drawing tools. And coming to the charging IC, so what we discussed earlier, we will work on our charging IC. And this is my charging IC, I think. I am aligning my microscope here. So let me align it. Good. Good. Yes, my microscope is ready. So my charging IC is here. Good. Let me pull it down. So all my lovely brothers ready? I think you all are ready for the class. And this is my charging IC. Okay. And here you can see pin number 1. Done. This is pin number 1. This is my charging IC. For the charging IC, already I have sent the snapshot and it is BQ24. That is BQ. On the image, I'm not able to drawing. Anyway, it is BQ25A. BQ25A, it's my charging IC. Okay. So as per the data sheet, when I'm opening my data sheet, so I have downloaded its respected data sheet. So it is here only. Let me go for that charging IC. Okay. And here when I'm going for the charging IC, it is saying like this, and these are the requirements. Okay. So let me go little bit depth here to understand the charging IC. Yeah, here I have got my charging IC. Okay. And I have the schematics I don't have, so that's why I'm working on this. So if you see carefully, what is my first pin I have to check? This is my first pin, VCC, correct? Next AC detect, third AC OK, then AC in. This all I have to check, correct? So as per the schematics, so this is page number 15. Let me go here little bit up, page number 15. So let me go little bit up. 735, 735. So I have one 735. Let me see if I have any other. So downloads, where did I download it? Wait, BQ25A, BQ25, yes, BQ25A. Just now I downloaded it. Anselmi, are you online?
Yes, sir. I'm online, sir.
Oh, sorry. Oh, correct. That is different. I was supposed to go there. Okay, done. I got it. So Anselmi is online.
Yes, sir.
Good. 25A. I got. This is my charger IC. Is Anselmi online?
Yes, sir. I'm online, sir.
Very good. I am doing a practical, Anselmi.
Yes, sir. I've been following almost some 8 minutes now, sir.
8 minutes. Good. Yeah. So here I am going for the block diagram, and the first confirmation is VCC pin number 20, correct? So let me copy this VCC and understand what it is. So I am going for my first pin. Okay, this is my second pin. This is my third pin. This is my fourth pin. Clear? This is how we have to go. Am I right? So let me go to VCC pin number 20. If I go to my section here, little bit up, what you will see for pin number 20, let me show you. Come on, description. Yeah, here 11, 12, 20. If you see here at pin number 20, input supplied diode or from adapter or battery voltage, use 10 ohms resistor and 1 microfarad capacitor to ground a low pass filter or limit in rush current. Understand this word, in rush current. Always I have told you, in a charger IC, if there is any voltage passing inside, there will be a resistor. Am I right? There will be one resistor. Correct? So VCC, you can see a resistor here. Here also, that is what he is trying to tell. So pin number 20, in my microscope, it has to show me a resistor. So task manager, I will go to AMCam. It is not working. Let me close it. So I am going for a microscope. Okay. So pin number 20. If you see carefully, where is pin number 20? This arrow mark is representing me pin number 1, and this is pin number 1. 1, 2, 3, 4, 5. So if this is 5 pen leg, this is 6, 7, 8, 9, 10. Okay, 11, 12, 13, 14, 15, and this is 16, 17, 18, 19, 20. So this is my pin number 20. So always pin number 20, there will be a resistor and there will be a capacitor. So let us check for the resistor and the capacitor. Okay, here pin number 20, if you can see, I have a V in capacitor for the filtration, and this is my 10 ohms resistor. You can see 10 ohm resistor. So I should get, what I should get? I should get my 19 volts present here. Okay, let me check. For 19 volts. Okay, no issues. Okay, small cameras. So I have a multimeter. Okay, and now this will explain me about 19 volts. Let me fix one camera, or let me go with the microscope itself. Okay, that will be better. I will go with microscope. Okay, pin number 20, I have connected DC jack. Once I connect DC jack, my DC jack is showing me 15. My DC jack is showing me 15. So pin number 20, you can see I am keeping at pin number 20. It is showing me 18.89 volts. So let me keep at the register. It is showing me 18.89. Here also let me check. It is showing me 18.89. So always this resistor is used to control the current, okay, not the voltage. And this is my first V in capacitor. So already it is proved that my V in is okay. You understood? Lovely brothers.
Yes, sir. Understood, sir.
Exhausted. Now let me go to page number 15 and to the second part. In page number 15, second part, what it is trying to tell me? Is it page number 15? Hello? Hello, answer me.
Yes, sir. I'm online, sir.
I want to hear your voice.
Okay, sir.
AC detect. Okay, AC detect is my second part. Okay, the voltage divider. AC detect. This should come to me. Okay.
Yes, sir.
So AC detect, which is the pin number? Let us see. Why I am not getting the drawing?
I'm in class, that's why.
Wait.
I'm your class, okay. Your class, your class.
Yeah, got it. So it is pin number 6, AC detect. Okay. So it is my page number 14. AC detect page number 6. So let me go to 4 and come back to 14. So pin number 6, you can see pin number 6, it is written as adapter detection input program adapter valid input threshold by connecting a resistor divider, that means voltage divider, from adapter input to AC detect pin to a ground pin when AC detect is above 0.6 volts and VCC is above UVL voltage. REG and LDO to generate is present, AC okay, comparator and current out are both active, that means this should be above 0.6. So let me check at pin number 6. So pin number 6, how much it should be? Pin number 6, how much it should be? Answer me.
Yes, sir. It should be 2.6 volts, sir.
Are you sure? But it has written 0.6 volts here.
Sir, it said it should be above 0.
योगी बोलिए माँ.
Above 0.6.
ठीक है माँ.
So it can be.
मैं क्लास में हूँ, थोड़ी देर में मैं आपको वापस अपडेट करता हूँ.
Sir, that's what he said.
ठीक है ठीक है ठीक है ठीक है. So answer me, you can see that my pin number 6 is connected to a capacitor and my multimeter is showing me 1.5 volts. How much it is showing me?
Yes, sir.
2.6 volts it is showing me.
1.5 volts.
No, 2.6. My multimeter is showing me pin number 6, 2.6 volts. It is showing me 2.6 volts. Okay. So if this is coming 2.6 volts, what is my next confirmation? AC okay.
What he said earlier,
Answer me, audio gone. My next confirmation is AC okay. AC okay, pin number 5. So AC okay is telling me AC adapter detection open drain output, it is a pulled high to a pull up completely rail by external pull up resistor when voltage on AC is below is between 2.4 to 3.15. Okay, AC okay. So page number 14 we'll check what is AC okay. So you can see AC okay, pin number 5. How much it should be? 2.4 to 3.15.
3.15.
Okay, pin number 5, I am going for the AC okay. And this is my pin number 5. So this pin number 5, it is showing me zero volts. I am not getting any volt. It is showing me 3.4 volts. Okay, it is showing me 3.4 volts, and here as per the reading it should be 2.4 to 3.15, but my voltage is more. Okay, my voltage is more. Let me go to the schematics. So the schematics will be not very far. The schematics will be here only in this, because physically this board schematics is not available. That's why I am following the data sheet, or it would have been very easy for me to follow the schematics and troubleshoot very easily. But unfortunately schematic is not available. I have to follow data sheet only. So I think here is my data sheet. So first is my AC in. AC in, it is coming from the CLR plus capacitor. Second, I have to check for the voltage divider. Voltage divider is AC detect. Correct? Third, if AC detect is okay, this will release.
Yes, sir.
This will release AC drive, first MOSFET switching. So, and for the SM bus it is releasing AC okay. I told you about I2C. Let me come little bit clearly. Battery drive here, VCC, V in capacitor, battery drive. I need an adapter confirmation. Where is the adapter confirmation? Battery adapter. So what is the pin number of AC in? We have already checked. AC present, that also we have checked. So and AC drive, AC direct. This is an voltage divider. AC direct. I have to follow AC direct page number. I'm not getting pin details here. That is my little bit small question. So let me go to 36 to 4. AC direct. So AC direct, what it will try to explain me? AC direct is trying to explain that it will be 0.6 volts. Okay. And AC okay, it is trying to tell me 3.15. AC drive is telling me 2.4 to 3.15 volts. So pin number 4, let me check here only, it will be better. So pin number 1, AC in, negative positive, AC drive is pin number 4. So let me check at pin number 4. I don't need to go there, I can check here itself, pin number 4. So if you go for pin number 4, this is pin number 4. Pin number 4 is 0 volts. You can see this pin number 4 is showing me 0 volts. I think this is the problem here. Okay. So pin number 4, AC drive, charge pump output to drive both adapter input N channel MOSFET and reverse blocking N channel MOSFET RB FET. Voltage is 0.6 is 6 volts above CMSR when voltage on AC direct is between 2.4. So AC direct is a clue for this. AC direct, it should be how much? 2.4 to 3.5. So I will go with pin number 6. So I will go with pin number 6. It should not be more than 3. Sorry, I moved the IC. Yeah. So it should not be more than 3.15 volts. Let me go here. Pin number 6. It is showing me 2.6. That means my AC direct is okay. 2.4 to 3.6. It is showing me 2.6 volts. Okay. This is showing me 2.6 volts. So this is okay. But AC drive, why it is not happening AC drive? This is my important. Okay. So pin number 4. Let me check at pin number 4. So this is pin number 4. And pin number 4, now it got 25 volts. Yes, 25 volts it is coming. Sir, that means this is also okay. 25 volts, this is also okay. So let me power on the laptop whether it is powering on or not. Still, it is not getting powered on. So when I check here for the voltage, no voltage, standby 5 volts is okay, 3 volts is also okay. Anyway, we will not work on this now because I think I have almost wasted too much of time behind this. Let me go for something better. Okay, I'm really sorry. I think I have taken too much of time for this. It is not required. I'll close this camera. I'll close this. Okay, because it is my iftar time, almost time over. Sorry, I wasted my time. I would have not worked on that motherboard. Anyway, so let me come for the proof. Okay. Anyway,
I would have not wasted the time. I wasted time. Let me come a small details. I'm really sorry for that. You can see here the first confirmation. What I was trying to prove you was out of this too much noise in the background. That is answer me over smart. God of Gania. So 1. So next is, where is my voltage divider circuit? It is here. 2. When these two are present, this will release AC present, that is my 3. When 80% is released, this will release my AC drive, that is 25 volts or 28 volts. And as I have told you, these are the information coming from the battery, serial data, serial clock. Okay, this information is coming from the battery to the charging IC, from the battery to the charging IC, and the same will go to the IO control also. Okay, to the IO control also. These are a basic, but one thing I would like to tell. So after the switching of the first MOSFET, okay, as I have told you, this voltage will come here. You will have a current sense. You will have current sense positive. Current sense positive to an information confirmed to the charging IC. The opposite side of the CLR you will get as current sense negative. So these both are telling the charging IC about the current. Okay, remember about the current, negative and positive. So the same information, it has to get a feedback. That means when my charging is completed, or my PWM is working, you will get a information coming back to the IC telling that my output, that is input, this is output of current, and this is positive and this is negative. Okay, output negative. These are the one more resist coming here. So between these two, one is negative, one is positive, there is one capacitor for the filtration. So this is filtration of not voltage, filtration of current. Okay, filtration of current. So always filtration is required. The same filtration of current I will show you here also, where the same filtration of current is present here also. You can see a filtration of current here also. So positive means positive current filtration, negative means negative filtration of current. So this filtration is used for current. Okay, filtration of current of positive, filtration of current of negative. It is not voltage. So always this capacitor will show short. Why it will show short? Because it is connected to a 0 ohms resistor. Okay, it is connected to a 0 ohms resistor. But here also you can see it is a 0 ohms resistor. You can see it is also 0 ohms resistor. Yes, Yogi. ठीक है. मेरे को व्हाट्सएप कीजिए, नहीं तो टेलीग्राम कीजिए. मैं थोड़ी देर में कॉल करता हूं, क्लास में हूं. ठीक है, इंशाल्लाह कोई प्रॉब्लम नहीं होगा, फिक्र मत करो. ठीक है. This also shows me a 0 ohms resistor. Because this shows a 0 ohms resistor, the voltage will come here and you have a positive and negative. These are output, but this voltage is my input. So I have two CLR. How many CLRs I have? I have two CLR present. Mane current load resistor. I have how much? One. One is for the adapter confirmation. One is for the battery charging confirmation or any voltage coming from the battery. Okay, so these all are ground pins, these all are data pins and clock pins. This is related to my complete voltage adapter information, and this is completely related to my output. This battery drive, that means this will go to my discharging MOSFET gate, discharging MOSFET gate. Okay, and phase boost, this part I have to complete. Inshallah I will teach you this also, but still almost it is my iftiari time, sorry for that. So coming back to the subject, we were in charging section. Let us go to the core of the charging section. Okay, coming to the core of the charging section, please, I would like to address some things and listen carefully what I am trying to tell. I would like to open some more schematics here. Okay, I would like to open some more schematics. So page number 39, ISL 6521. Wait and watch. Okay, ISL 6521, I will open that also. Okay, two charging sections I will teach you, and the third automatically you will explain me, and one member is going to speak to me. ISL 6251. Done April 12th. Okay, done. Okay, ready? Yes, all mute your mics and listen carefully. So who will connect to me and speak to me? Welcome Osai Frank. Who will speak to me today? No issues. I will continue the class. Listen carefully. Okay. So my loving brothers, today we are going for the charging section of the common board R62 what we are learning today. And before going this is a simple circuit. Okay, this is a simple circuit. The charger IC number is BQ24738. So I have opened a schematic data sheet of BQ24738, which is easily available in the Google. Okay, so from here I have taken the data sheet, point number 1. So I have opened one more, that is compact. The charging IC is ISL 6251. So I have taken that data sheet also. Done. I have taken that data sheet also. So let us see here how to understand a charging IC. Before understanding a charging IC, I would like to tell you that whenever I am speaking about an IC, suppose this is my IC. Okay, whenever I am speaking about this IC, the IC is divided into two parts. Okay, one is my input part. Second, the IC has an output part. So usually in IC I have one input, I have an output. Okay, so when the output is going to work, the question is when my output is going to work. The answer is whenever I get a permission. I should get a permission. So now I have an input requirement, I have got a permission. So this will be my first scenario. That means the input requirements must complete. Second, I should get a permission. What is that permission? To start functioning. So when I have got a permission, the output is going to start. So this I am telling about an IC. Okay. Now what are the requirements of an IC? So if you put step by step, like the first is my, I'll start from the left. I need a voltage, I need a ground to complete the circuit. I need all requirements. That means I need now some few requirements and confirmation from the IC. I need time, I need a semiconductor circuit, that is my DC circuit. I need an output, I need a feedback, I need a power good, final. So these are some basic things which we have to learn in an IC. Okay, so let me take it in step by step. Let me start from here. Okay, so when I'm speaking about the charger IC, the charger IC, as I told you, it is divided into my battery connection, my adapter connection, IO requirements, my IC, and my DC circuit. In this, I need complete information about current. Okay, because charger IC is a game of current, it is not a game of voltage. Okay, so let us put a small chart here. Adapter confirmation should go to IO controller. How it will go? It will go from the charger IC. Adapter voltage will reach the charger IC. 1, 2, 3. Okay, this is one part. Next,
battery connection signals will go to IO controller. Sometimes it will go to charger IC also. That's why I am putting in dots. Sometimes this will go to so these are my data and clock. Understood? This is my data line, this is my clock line. So this data and clock, sometimes it will go to charger IC, but mandatory this has to go to my IO controller only. Hi. Got my point, brothers? This is one thing. So now there is one more confirmation to the IO controller telling that battery present. So this chart, it will be to my, this is A 1 2 3 and here it will be my B. In B it will be 1, clock will be 2, battery present will be 3. Okay. So how will the IO controller understand the battery present? With the help of temperature. Okay. So it is complete a current sense. So this circuit is called as I2C. That means communication, current communication or smart IC information reaching the IO controller. So any IC which has an I2C communication support can read my battery. So this is B. Now we'll go for the circuit number C. So in circuit C we have here, this will explain me about the charging of my voltage. Okay, when it will charge, when the battery is present, the IO controller will give an enable message. Okay, this circuit should start. When this circuit is starting, so we have one final adapter current information should go here. Okay, the adapter current information should go here as input and same charging information should go here as output. So this is a chart of our charging IC. Is my audio clear? Understanding my language, brothers? Are you getting my accent?
Yes, sir.
Good. Mustafa is understanding my language. So you don't have audio problem. Am I right?
Yes, sir. Very clear, sir.
Okay, good. So you don't have audio problem. We'll continue. I would like to tell some small clues here. Okay, when I am speaking about the data sheet. What is this? This is the data sheet of an charging IC. Okay. Here I have ISL 6251 and 6251A. What is the meaning of A? A means the IC is changed. Here it is in square shape. Here it is in rectangular shape. Okay. So ISL 6251 has 28 LQF pins, and here you have 24. What are these LQF? It is called as LCC. LCC means legless chip carriers. This IC doesn't have any legs, but it has soldering pads on it. Okay, these all are the soldering pads. Even this doesn't have legs, it has a soldering pad. Understood? So we have 28 legs as well as we have 24 legs. So 28 legs, it is represent to ISL 6251, and 24 legs it is represented to 6251A. Okay, so this one part it is clear. How to read a charging IC requirements? I'll tell you some important tips. Please understand step by step. So maybe it is in page number 15. Exactly, I don't know, but let me check it out. No. Yeah, I want to tell you some more thing, that whenever you don't get a schematic, any motherboard, if you don't get a schematic, you can do a simple way: download the data sheet of that IC. Automatically you can see, you will get the schematics here for that specific IC. So this is a schematic. What is I mean to say about schematic? Schematic means the outer layer before, outside the IC, it is called as schematics. The IC explains about data sheet. This is data sheet, requirements of IC, or how the IC is going to work, and this is schematic. Schematic means the outer components connected to the IC is called schematics reading. The drawing, the different drawings. Okay, the component drawings is schematics. The IC requirement working condition is called data sheet drawing. Okay, so here I have explained about data sheet, and this is my schematic data sheet. Okay, this explains completely about my charging IC data sheet. Done? Yes. The first important is my DC in. So what DC in? DC is my V in voltage. When V in voltage is injected inside the IC, a drive voltage is released. It is called as low drop output. Okay, we have an internal regulator IC which will generate a low drop output. Why? Very important thing. This is a clue which tells me that every IC will work not more than 5 or 5.4 volts highest. 5.6 volts I can tell it is an highest. Okay, this is the highest voltage. With this voltage we can drive this IC. Drive means to start only, but with the high voltage it cannot run. It needs a lower voltage, 5.4, 5 volts. Very important. So in future also, whenever you see 5 volts, it is nothing but it is used to drive an IC. So here in my motherboard I have only one voltage present. Which is that one voltage present? It is my V in. It is my V in, but V in is my 19 volt. So it will be difficult for me to drive this IC. So this IC has to automatically generate. So this will automatically generate a low drop output voltage. The question mark is why? Why means to drive.
Understood? Point number 1. This voltage is going again as a VDDP, that means drive power. So the low drop output, how much it will be? It will be 5.4 volts. Maximum 5.6, sometimes it will be 5.4 volts. So 19 volts is converted to 5.4 volts. So this is point number 1. Now let me go to the point number 2. Okay. So high voltage is converted to low voltage to drive this IC. Now I need an adapter confirmation. So what is the adapter confirmation? This is my second part. AC set is my second part, and this is my one more chart. So AC set, how it is generated? AC set is generated with the help of a voltage divider. I have taught you this voltage divider. So one end will be connected to ground and another end will be connected to my V in. Okay, so this is my second important confirmation which has to come. When this voltage will come, it will be around maximum 3.1 volts highest. Depends upon the motherboard. Maybe it is 3.1 volts. I have seen highest 3.1 volts. It can be start from 2.4 to 3.4 highest. Okay, 2.4 to 3.1 volts highest. If it is 3.2 also, it will not work. There is a problem in this resistors voltage divider. Now when this information is going inside, now let us start the chart. When the information is going inside, that means it is representing a positive. What is it is representing? It is representing positive. What is positive? This is a logic IC which explains. Okay, I don't want to go for a NOR, AND gate, NOR gate, NOR gate, NOT gate. I will not go so much deep. Simple explanation. One point is positive, one point is negative. So if the positive is more than negative, the output will be positive. Getting my point? So what is my positive? It is 3 volts. Example, it is 3 volts. So what is my negative? It is 1.26 volts. So my positive is greater than my negative. The result will be positive. That means it will be an high logic. When I am getting a high logic, you can see that this is a JFET. So what happens? The JFET will go to on condition, and the ACPRN here in this architecture is converted to ground. It is converted to ground, or I can tell as a low logic. That means it will be negative. So here AC present, ACPRN means AC set. That means adapter is confirmed. ACPRN adapter present, information is coming ground, and this information in future, that means it is followed again with one more circuit. This is followed again with one more circuit, and this circuit will reach my IO controller. And when this circuit will reach the IO controller, this will be converted to 3 volts. So this is one part. So it can come from here to here. Sometimes, but default, this AC present here itself will have, that is second type. One type you understand, brother. When this JFET goes to on condition, ground voltage will come up. Am I right? Yes, this ground voltage will come up. Why? This JFET will go to on condition. I have explained completely in
previous classes. Okay, when this ground voltage will come up, that AC present is now low, that means negative. But before reaching IO control, this should be converted to 3 volts. So I will have a DC circuit here which will convert it to 3 volts. But in some other architectures, this AC present, but default will be converted to 3 volts. So I will have a direct line to the IO controller. This is the second architecture. But what is my intention? The intention is the adapter present confirmation going to the IO controller, it should be high logic. Okay, here it is high logic. This is important. And this is called as AC in. And these are called as AC OK. So this is my second important part. Okay, this is first important part. Now listen carefully. Coming back, when the low drop output is released, listen carefully. When the low drop output is released, you can see here VDDP. From where it came? It came from here. So this will release a reference voltage confirmation, and this reference voltage confirmation will be 2 volts. If this confirmation is not released, that means there is a problem here or there is a problem in this low drop output. So this is my point number 3. I told you confirmation. In step by step points, I have told you confirmation. To complete the circuit, I need ground lines. So let us see how many ground lines are there. Ground line number 1 will have ground line number 2. Here it is normal ground, here it is power ground. I will tell you why it is called as power ground. In some circuits, when DC in, that is first part, and second part confirmation is given to the IO controller, this will release, in some circuits, not every circuit, this will release 28 volts to switch the first MOSFET. 28 volts to switch first MOSFET. This is going to the first MOSFET gate. In some circuits, this 28 volts is used from VH28 IC, okay, voltage high 28 volts IC, and in some circuits, this charger IC itself will give 28 volts to switch the first MOSFET, okay. Switch first MOSFET gate, okay, done. So this is an optional. In some circuit it's available, in some circuits it is not available, but if it is available, you have to trace, and if first MOSFET is not switching, that means there is a problem in the IC, or in future there is a V in line short. Done? Okay, good. So now this is ready. This IC is ready, and this will work only when battery is present. Why? The requirements are completed here. The requirements are completed. Okay, but when it will work? Only when battery is present. As I told you, the battery present, data and clock will go to the IO controller, and temperature also will go to the IO controller. But in some circuits,
where the first MOSFET is getting 28 volts. In that type of ICs, data and clock will go to the charging IC also, but in this architecture we don't have data and clock. Okay, that means this data and clock are going only to the IO controller. So whether the battery is present or not, automatically there will be a search signal, search data signal search will come and clock signal search will come. If it is present, that means if the battery is charging, automatically this will start, you will have a continuous pulse. If the battery is not present, this will search, it will come and it will go. Now this IC requires an enable. This IC requires an enable. So sometimes the enable is given. What is enable? Enable is nothing but a message I can tell to on a switch. It's like a switch. Enable is nothing but to on. What to on? This IC. Sometimes the enable is given from my AC present. Sometimes the enable is given by IO controller. So it depends upon the architecture. So what I am trying to tell you is every IC cannot be same. It depends upon the architecture. If you know how to read schematics, if you know how to read my data sheet, then it is very easy for you to start. Okay, now we'll come back to the chart now. You saw that 2 volts reference is released. This 2 volts reference, it is going here. This 2 volt is converted to a voltage divider. That means my current limit, adapter current limit, and this will tell you adapter current limit set, and here you will have a confirmation. So this again you have a logic IC, negative and positive, whether it has to go for a high logic or low logic. Understood? Then how it is confirmed? Okay, so when the first MOSFET is switched, you will receive a CLR here. You might have seen a CLR, which I have taught you many times. I have showed you in the board also. The left side is called as positive line. This is my positive and this is my negative. Means it is not voltage, it is current. The voltage both the side is 19 volt only, but the left will have positive current. That means current sense input positive. The left side is called as current sense input negative. So the current is calculated into 19.9 times. That means here you will have high logic by default. It is nothing but my 19 volts. Okay, so here I have 19, here I have 19. That means here you will have a low logic. Correct? Because it is opposite. Here you have 19 volts. Here you have how much? Maybe maximum 1 volt. So it is a reverse answer here. The same current will go same from the op-amp logic IC, and you will have current sense. So what you are understanding, the whole IC is a game of current. Okay, the same negative will come here, minimum current buffer. So you have negative, minimum current buffer, and you have here. So before coming to the current output positive and voltage current positive, I will explain you this one. So here I told you we need an enable. Here the enable is given by an voltage divider. Who is my voltage divider in this IC? It is my AC present. Here this one AC present. I told you voltage present is coming. Okay, AC present. Here this one AC set. Okay, or I can tell a short form as AC. Okay. Okay, when enable is given, that means I am giving a high logic. So this will be 3 volts. So the 3 volts is greater than negative. You can see the 3 volts is greater than negative. Here I have a positive. This is hitting to an op-amp. Op-amp amplifier IC. That's why it is called, you have a symbol, it is a microcontroller. What is the working of a microcontroller? I will teach you. You have a left, you have a right. That means you have an upper part, you have a lower part. So this upper part is connected to my upper MOSFET. The lower part is connected to my lower MOSFET. Okay, so boot, the boot is connected with a diode here. So for the boot we have 3 things. One, see what are the requirements of a boot? Listen carefully. One, I need a diode. I will call it as a bootstrap diode, and I need a resistor and a capacitor for pumping. Okay, so for when I'm speaking about boot, the boot will be connected to VD, that means drive voltage. So the VDD voltage is going to bootstrap. In between you'll have a resistor and capacitor. Okay, so here I will have an high voltage. Lower gate, that means this line is connected to my lower MOSFET gate. The upper MOSFET drain is connected to my VIN. Okay, so I have a boot pump, I have a VIN voltage, I have lower gate also. So when this is connected, you will have an high pulse working here. Understood? And high pulse will be working here. Part 1. Phase. Phase is nothing but the output is connected to the phase. Okay, and here you will have a coil and one capacitor. So the phase means the upper MOSFET and lower MOSFET connection is called as phase. The same we have here also. See here, VDDP, drive power, it is nothing but the connection from a resistor. That means it is nothing but my drive voltage only. Lower gate is connected to my lower MOSFET gate. Simple, it is connected to lower MOSFET gate, and this is connected to my phase. This is connected to my phase. So upper MOSFET source, that means S1, lower MOSFET drain means D2. So S1 means first MOSFET, second MOSFET 2, first MOSFET 1, second MOSFET 2. So first MOSFET source I will call S1, second MOSFET drain, that's why I called as 2. Okay, drain of the second MOSFET. Second MOSFET drain, first MOSFET source. Okay, and the lower MOSFET source is connected to my ground. Lower MOSFET source is connected to my ground. Drain, source, gate. Got it? So when this MOSFET, the upper MOSFET, when the upper MOSFET goes to on condition, the lower MOSFET will go to off condition. This is the work of an op-amp IC, microcontroller op-amp IC. When the upper MOSFET is on, the low MOSFET will go to off condition. When the upper MOSFET is on, you will have an high pulse coming here. When the lower MOSFET is off, now the upper MOSFET will go to off condition. Now the lower MOSFET will go to on condition. Okay, the lower MOSFET will go to on condition. When the lower MOSFET will go to on condition, whatever the high voltage here, it will go to ground. That's why it is called a power ground. It will discharge, and this ground voltage will be reaching here to generate a ground pulse. So this is called my PWM output voltage. Okay, now these two feedback coming from the coil, the two feedbacks coming output from the coil is called as current sense output, positive and negative. So this current sense output positive and negative will go here. One will go here and another will go here. Now you got the point. So this cells voltage adjustment with the help of the reference, the same reference here, it will adjust the voltage. That means in the battery we have different total will have 4 cell or 6 cell. Okay, now every cell should not charge at a time. It will start step by step. First this one should charge, second the second shell has to charge, third the third shell has to charge. So this will tell an adjustment, and it will get a confirmation how many shells are charging, because different shell. When I'm going for the first cell, the ampere will be low. When I'm going for the second shell, the ampere will be more. When I'm going for the third shell, the ampere will be still more. Okay, here the everything is a game of current. Okay, current confirmation, voltage confirmation is given to the IO controller, and this is all about current limit. So this is about my charging IC one part. I know this is complicated, but still you will understand when you see the video. I know this is the dosage is little bit big. Parvailla barri. Hello gentlemen. Abdul Rashid. See, you can see the dosage of the charging IC. Yes, it is complicated, but inshallah I will tell you now again. Okay,
Very interesting.
you think it is complicated?
Very interested, but complicated a little bit.
If you see the video 2 or 3 times,
No. When we see the video 2 or 3 times, we'll be clear, inshallah.
inshallah.
I
Frank,
have not seen like this before. I've never seen like this before, but it's very interesting.
inshallah, I will teach you one more point. Okay, now let me take one more 15 minutes now. I have told you about my HP architecture. See, this is what I am trying to tell you. Okay, now as per the architecture, what I was trying to tell you, HP, yes, charging IC, yes. Where is my pen? Yeah. As you all know, VA means voltage coming from adapter. This is going here. So you can see DC in. It is my 19 volt. So if my 19 volts is coming, I need a confirmation that adapter is present. So this is my voltage divider circuit which is coming from the VIN. This is telling me that it is an enable to start the IC. Oh sorry, this is an enable. Here you have an voltage divider. You can see voltage divider. AC set. When these two are present, this will release ACPRN. So this should be
you can see hash mark high logic or low logic. But before this goes to IO controller,